Hello everyone, this is our first video of the series Maths in 3. In this video, we are going to start the topic Permutations and Combinations. The topic Permutations and Combinations comes under combinatorics. Combinatorics is the branch of mathematics in which we study about counting problems. To study probability theory and binomial theorem, we must have a pre-knowledge of the topic Permutations and Combinations. Here are some of the topics listed which will be covered in the 3 videos of Maths in 3 for the topic Permutations and Combinations. So let us start our topic. First, let's get an idea about permutation and combination. So permutation means selection plus order, means selection in a specific order, while combination is only selection. Suppose there are some numbers 1, 2, 3, then 1, 2, 3 is one of their permutation, and 2, 1, 3 is their another permutation, 3, 1, 2, 3, 2, 1, etc. are the permutations, and in this way several more permutations can be formed. So these are permutations. Each one of the formation here is a permutation. Now in the case of selection, order doesn't matter. Suppose we have 3 numbers 1, 2 and 3, and this time we have to find sum of any 2 or 3 or whatever. So 1 plus 2, this time 1 plus 2 is equal to 2 plus 1, or 1 plus 2 plus 3 is equal to 3 plus 2 plus 1, and in this way 3 plus 1 is equal to 1 plus 3, etc. So you can see that order doesn't matter. So in this situation, in this kind of problem, we will use combination. So 1 plus 2 means it is a combination of two numbers 1 and 2. So it comes under combination. Okay, so this was an idea about permutation and combination. We will discuss it in deep later. Let's start with fundamental principle of multiplication and addition. So what is fundamental principle of multiplication? If we have to do a work and it completes in 2 phases, first we have to do work 1 and then we have to do work 2, and then it will be finished. We do work 1, then we do work 2, and then work is finished. So here the total number of ways to do our work will be equal to the total number of ways in which work 1 can be done and multiplied by total number of ways in which work 2 can be done. Moreover, the multiplication is associated with the word and. So you will usually find this word and in the problems where multiplication is to be used. We will take an example and it will become clear. Similarly, addition is associated with word or. If we have to do a work in which we have two possibilities, either we do work 1 or we do work 2. So sorry, here we started, and after doing any of the work 1 or work 2, work is finished. So in such problems, the total number of ways in which work can be done is equal to the number of ways in which work 1 can be done plus the number of ways in which work 2 can be done. Now let's understand these with the help of examples. So example for fundamental principle of multiplication. Suppose we tossed a coin and a die simultaneously. Okay, so now we have to find the total outcomes. In the cubic dice, there are 6 possibilities there are 6 possible numbers which can occur on the top, and in the coin there are 2 possibilities. So the total number of ways are 2 multiplied by 6, that is 12. Why? Because on the coin, with the head we can get a 1 on the die, with the head we can get 2 on the die, with head we can get 3 on the die, and in this way there are 6 possibilities with the head. Similarly, there are 6 possibilities with the tail too. So in total, these are the combinations which can occur. These are the pairs which can occur on coin and die. So in total, there are 12 ways, 12 total outcomes. Let's take another example of a hall with 6 faces, 6 doors. Now we have to enter the hall from any one of the faces, one of the doors, and then we have to exit. But entry gate should not be the same as exit. Now how many ways are there? Since there are 6 doors to enter, 1, 2, 3, 4, 5, 6, in total there are 6 ways to enter. So, we have to enter as well as we have to exit, means we have to enter and exit. So here multiplication will be used. So 6 possibilities to enter, and if we choose any door and enter, so we can exit from there. So there are only 5 possibilities for exit. So in total there are 30 possibilities. Next example is formation of a 3-digit number using 9, 4 and 1. So since we have to make a 3-digit number, we have to choose our first digit, we have to choose our second digit, we have to choose our third digit. What are the possibilities for first digit? It may be 9, it may be 4, it may be 1. Second digit is also maybe 9, maybe 4, maybe 1, and in third digit also it may be 9, it may be 4, it may be 1. So for every digit we have 3 possibilities. So 3 times 3 times 3, that is 27. Means there are 27 3-digit numbers in which either 1, 4 or 9 is used, or all are used, or only 4 are used, etc. Now example for the fundamental principle of addition. Suppose there is a class in which there are 17 boys and 12 girls. Now we have to choose one class representative from these students. One class representative. So what can we do? We can choose either a boy or we can choose either a girl. So we have to choose a boy or a girl. So in such case we will use addition. So in total there are 17 boys and there are 12 girls. Means we have 29 ways to select a class representative. Another example is formation of a number using 5, 4, 3, 2, 1. We have to make a number less than 1000 using the digits 5, 4, 3, 2 and 1. It is something different from the previous formation of number which we have just discussed. Here the number may be a 1-digit number or a 2-digit number or a 3-digit number. Using the digits 5, 4, 3, 2, 1, we can make 1-digit number, 2-digit number or 3-digit number. So we will find all the numbers which can be formed, all the 1-digit numbers which can be formed using these digits. Then we will find all the 2-digit numbers which can be used, which can be formed using these digits, and all the 3-digit numbers, and then we will have to add, because here OR is used, 1-digit number or 2-digit or 3-digit number. So how many 1-digit numbers can be formed? There are only 1, 2, 3, 4, 5 possibilities, because these are the digits which are given. Now for 2-digit number, suppose first digit, sorry, we have to do two things. First we have to choose our first digit, then our second digit. So what are the possibilities for first digit? We can choose any 5, we can choose any one from 5. Okay, now for the second digit, it is not given it is not given over here that repetition is not allowed. So we have five possibilities. We can repeat a number. So suppose we can make 55, we can make 44 also, we can make 41 also. So it is not given whether we can repeat or not. So we will allow the repetition. Now for a 3-digit also in the same way, the first digit may be 5. Uh, First digit can be chosen from the 5. Similarly, second can be chosen from any of the 5, and similarly third can be chosen from any of the 5. Now on adding all these, we get 5 plus 25 plus 125, that is equal to 155. Now let's see some notations which are frequently used and which are important for this chapter. So n factorial, sometimes also written like this, is the product of first n natural numbers. For example, 5 factorial is equal to 1 times 2 times 3 times 4 times 5, which is equal to 120. 0 factorial is equal to 1, and factorial of negative numbers like -1 factorial, -2 factorial, etc. is not defined. Okay, from these notations it is clear that in n factorial, if we leave n, then the remaining part is equal to n minus 1 factorial. So n factorial is equal to n multiplied by n minus 1 factorial. Also, it can be written like n multiplied by n minus 1 multiplied by n minus 2 factorial. These notations are many times used in calculations. For example, suppose we have to find 15 factorial over 10 factorial times 5 factorial. Now 15 factorial can be written as 15 multiplied by 14 multiplied by 13 multiplied by 12 multiplied by 11 multiplied by 10 factorial over 10 factorial times 1, 2, 3, 4, 5. Now 10 factorial gets cancelled out, and in the remaining the calculations can be performed to solve it further. Now let us find the total number of permutations of several distinct objects when the repetition is not allowed. Suppose several objects are given to us in which all are distinct. What does this mean? Means if A, B, C, D it is given to us, it will be considered, but if A, B, B, C is given to us, it will not be considered in this case, in this discussion, because here B is repeated. Okay, so suppose n distinct objects are given to us. Now we have to choose, we have to select any R from them, and then we have to perform their permutations, and we have to count all of them. Okay, so suppose there are R places. In total there are R spaces or R places, and we have to fill each of them one by one. In the first place we have in total n possibilities. We can fill any of the n over here. Now for the second space we have only n minus 1 possibilities. Why? Because suppose some of the number from these, some of the objects from these is already used, so it cannot be used in the second place because repetition is not allowed. So for the second place we only have n minus 1 possibilities. Similarly for the third position we have only n minus 2 possibilities, and in this way for the last one we will have n minus r minus 1 possibilities. Why r minus 1? Because in the first place you can assume that it is written n minus 0, then 1, then 2, then 3, and up to r places we will reach r minus 1. Hence the total permutations of such kind, total permutations are equal to n multiplied by n minus 1 multiplied by n minus 2, and so on up to n minus r plus 1. It can be written as n factorial over n minus r factorial. How?
if we increase n minus r in both numerator and denominator, then there will be no change. So we can do this and we can write it something like this. It can also be written as NPR. This is the notation which we will use. NPR is the notation. It is used when from the n distinct objects we have to choose R and count their permutations. Now the case in which repetition is allowed. Now suppose we have n objects. From these n objects we have to take any R and find all their permutations. For the first place we have n choices. We can fill the first place with 1 or 2 or 3 or so on up to n. For the second place also we have n choices. Why? Because this time repetition is allowed. For the third place also we have n choices, and in this way for all the places we have n choices. So in total there are n raised to the power r ways to do this procedure. Let's understand it with the help of an example. How many 3-digit numbers can be formed using 1, 2, 3 and 4? We have 1, 2, 3 and 4. We can use these numbers to make a 3-digit number. So for the first digit, if we talk about the case in which repetition is not allowed, so for the first digit here also we have 4 choices. For the second digit, if suppose we have all filled 3 in the first place, so here 3 is not allowed in the second place. We only have 3 remaining choices, and for the last place we have only 2 remaining choices. So in total there are 24 3-digit numbers which can be formed using the digits 1, 2, 3 and 4 if repetition is not allowed. Now if we see the case in which repetition is allowed, so for the first place we have 4 choices, 1, 2, 3 and 4. For the second place again we have 4 choices. Why? Because this time repetition is allowed. Means if we form a number like 112 or if we make a number like 111, so it is not a problem. They are allowed. So for the next place also we have 4 choices, and for the third place also we have 4 choices. This time there are 64 ways, means there are 64 such numbers which can formed using 1, 2, 3 and 4, and they are of 3 digits. Now let us see the permutations of those objects in which all are not distinct, means some of them are identical, like A, B, B. Here if we find the permutations of these objects A, B, B, so A, B, B is one permutation, B, A, B is another permutation, and B, B, A is third permutation, and that's it. With these 3 given objects or letters, we can have only 3 permutations here. Here if since there are 2 B's are of same kind, so if we interchange them or we try to find another permutation by interchanging or by keep fixing this A and interchanging only these B's, then it is not possible because the obtained result will again be the same. In general, how we solve this? For some time we suppose that both of these B's are different. This is the explanation. So we suppose that for some time we suppose that these two B's are different. Now if we try to find the permutations, so this time we have 3 different letters, hence in total we will have 3 factorial permutations: B2 A B1, B1 B2A and B2 B1A. In total we have 3 factorial permutations. But as we see, as soon as we will consider that this B1 is equal to B2, means both are identical, we will find that these 2 observations over here, these 2 observations and these 2 observations at the bottom are same as just made below, as just made here. So that's why we have to divide this by 2 factorial. Let us see with one more illustration. Suppose here we have A, B, C, D, D, D. We have to find total number of permutations of these letters. So for some time, suppose that these D1, these D's are different. They are D1, D2 and D3. If we assume that these are different, so this time we have 6 letters and hence 6 factorial permutations are possible. But for any random permutation, let us choose any random permutation, say A, B, D1, C, D2, D3. Here it will exist in pair. Means if suppose we fix the position of A, B and C and keep interchanging the positions of D1, D2 and D3. So we can write D2, C, D3, D1, D3, C, D2, D1. Obviously AB is here, and AB, D1, C, D3, D2, etc. Since there are 3Ds, here we will find in this box we will find 3 factorial permutations, and as soon as we will consider that all these D's are equal, means D1 is same as D2 and it is same as D3, all these cases will be treated as 1. And since this was a random selection, and in this way all kind of permutation, all kind of permutations here will exist in pairs of 3 factorial, and that group of 3 factorial permutations will be treated as 1 in this case. So we will have to divide 6 factorial by 3 factorial to find the number of permutations. Let's see it with the help of an example. Suppose we have to find the total number of arrangements of word banana. So in the word banana there are 1, 2, 3, 4, 5, 6 factorial, and repetition A is repeated 3 times, so we will write 3 factorial in the denominator, and N is again written, so N is again repeated, so there is one more 2 factorial in the denominator. These are the total number of ways. If we see in general, suppose there are some similar objects A and A is k1 times, then we have k2 times B, k3 times C and so on. So here total number of permutations are equal to k1 plus k2 plus k3 and so on, means the total number of given objects over k1 factorial times k2 factorial times k3 factorial and so on. Here is an example on its basis. Here we have 7 bulbs and we have to find their permutations. 3 bulbs are of same type, next 2 bulbs are of same type, and rest are distinct. In total there are 7 bulbs, so first we will write 7 factorial in the numerator. In the denominator, first we will write 3 factorial because 3 bulbs are of one kind and 2 bulbs are of another kind, so we will write 2 factorial. Writing 1 factorial doesn't change our answer. So these are the number of ways. Now we will see the number of permutations of object under certain restrictions. So first restriction, we will study that number of permutations of n different objects taken are at a time when one particular object is always selected. Suppose these are the given objects, n given objects, and it is said that 4 must be selected in our permutation. We have to make a permutation of any r of these objects, but 4 must be there. Since 4 must be there, so let us first select 4. What are the possibilities for 4? 4 can go in the first place, or 4 can go in the second place, or 4 can go in the third place, or it can go in the last place, and so on. So how many choices 4 has? If there are r places, means 4 has r choices. So our first work, first job, first operation has r choices. Now Suppose 4 is filled in some of the place. Suppose here we filled 4. Now this place is already occupied. In remaining we have only r minus 1 places left. In those r minus 1 places we have to fill the remaining objects, and since we have n minus 1 remaining objects, so uh, our question is to select r minus 1 objects from n minus 1 objects and find their permutation. And we have discussed in the video that it can be found by n minus 1 p r minus 1. So these are the number of permutations in which n different objects taken are at a time when one particular object is always selected. Our second restriction is something like this: number of permutations of n different objects taken are at a time when one particular object is never selected. This is just opposite of the previous restriction. This time we don't have to select 4. Rest of the objects can be selected, but we don't have to select 4. Here we have r places, and this time we have n minus 1 objects. Since one object is removed, so let us remove it from our given set of objects. So our question is converted into selecting and ordering r objects from n minus 1 objects. This can be done in n minus 1 p r ways. Now on the basis of these two restrictions, there is a theorem also. Suppose we have n objects, and one by one we write all their permutations. Now select those permutations in which 4 or any object is available. So any particular object is available. Suppose we select those permutations in which 4 was available and put them in the category of permutation 1 or P1. Now select those permutations in which 4 is not available. Obviously, since all the remaining permutations 4 is not available, and put them in the category of P2. Now let us see. In total, there are NPR permutations. NPR permutations are there in total, and permutation in the category 1, in the category P1, and in the category P2. If we add the total number of permutations of these categories, they will result in NPR. We have just discussed that in the category 1 means when the 4 is selected, the number of ways is r times n minus 1 p r minus 1, and in the category P2 there are n minus 1 p r permutations. So if we add these two, we will get NPR. This was our theorem. Now here is our third kind of restriction: number of permutations of n different objects when m particular objects are always taken together. Suppose we have three numbers 1, 2, 3, and we have three letters A, B, C, and let the restriction is given that letters should always be taken together. If the letters can always be taken together, then why don't we just pack them in one box? Let us suppose that these letters are not three letters, but it is one unit. For some time we will write it like one box. So what are the possible permutations? Possible permutations are like 1, 2, 3 box, 1, 2, box 3, 1, 3, 2, then box, then 1, 3, box 2, and in this way different permutations are possible. So what we are doing, we are finding the permutations of 4 different objects, means the total number of ways are 4 factorial. But wait, for any of these permutations which are shown on the screen, for any of these permutations, say we take this here, what does this mean? This means that it is written 1, 3, 2, A, B, C, because box represents this A, B, C. But second possibility is also there, 1, 2, 1, 3, 2, A, C, B.
Why? Because box represents that all the letters are together, but it doesn't mean that they can't interchange their position. They definitely can interchange their positions. So the third possibility is BAC, fourth is BCA, fifth is CAB, and sixth is CBA. Means for every permutation written here over here in the form of box, there are 6 more possible permutations. So we have to multiply 6 again over here. This 6 means this was actually 3 factorial. So more precisely we can write 4 factorial times 3 factorial. So let's see what we have done. First we have considered this unit. First we have considered ABC as one unit. Then now we have find the total number of permutations of these elements, treating it as one unit. Then we have multiplied it with the number of possible permutations within that unit. Now let's generalize the things. Suppose there are n objects and m particular objects out of them must always be taken together. So let's keep them in box. Now this is this will be treated as one unit, and here we have n minus m elements. So in total now we have n minus m plus 1 elements, treating it as one unit. So there are n minus m plus 1 factorial ways for their arrangement. Now we have to multiply it with the number of possible permutations within the unit, within this box. It is m factorial. Why? Because there are m elements in the box. Now let's take an example for this restriction. In how many ways letters of word brain can be arranged such that vowels are always together? So B, R, A, I, N, here A and I are the vowels. So let's treat them as one unit. Now in total there are 4 elements. So arrangements are 4 factorial. Now multiply it by the number of elements within the box. It is 2 factorial. One more thing should be noted here, that we are not multiplying just by the number of elements inside the box, but we are multiplying it by number of possible permutations within the box. Means suppose if there were 2A, if there were 2 A's, then in total there are 3 vowels. So what are the number of ways? Number of ways will become 4 factorial multiplied by 3 factorial over 2 factorial. Why? Because possible permutations inside the box are 3 factorial over 2 factorial. Now let's come to the circular permutations. Suppose we have 3 elements A, B and C. Now we try to write there another permutation like this, ACB. For some time it looks like we have written a different permutation, but it is not so. You see that here after A there is B, and here also after A there is B. After B there is C in both the cases, and after C there is A in both the cases. So in circular permutation, both of these permutation will be treated as one. Means these are not 2 permutation, it is 1. These are same. And similarly we can write A, B, C also. And if we want to make a difference, then we have to get some another sequence. Means after A there should not be B, there should be C. So this one is a different permutation. So this is how a circular permutation is different from a normal permutation. Now let's see how many permutations are possible when clockwise and anti-clockwise cases are treated as different. Again, let us suppose that there we have n elements up to n. As we have just discussed that their sequence with reference to any one of the elements, mean after 1 it is 2, after 2 it is 3, this sequence should be different for a different permutation. So what should we do? What can we do? Let us fix one of these elements. Suppose we fixed 1. Now any kind of change, we have fixed 1, which what it does this mean? This means that 1 will always be over here and we will find the permutation in rest of the elements. So now if we do any change over here, this change will result in a different permutation, because with respect to 1 or with this reference, definitely there will be a change in the permutation. This sequence will break. So now how many elements are there? There in total we have n minus 1 elements remaining. So what are the total number of ways for their arrangement? There are n minus 1 factorial ways. These are the number of ways when clockwise and anti-clockwise are treated as different. Let's see an example. In how many ways can 10 players be seated at a round table when captain and vice captain are always neighbors of each other? So there is a restriction also given here. There are 10 players, 1, 2, 3, 4 to 10, and captain and vice captain are always together. Suppose 1 and 2 are the captain and vice captain. Let's treat them as one unit. Now how many elements do we have? In total we have now 9 elements. For the circular permutation, we have n minus 1 factorial ways, as we have just discussed. But this time within this box there are 2 possible permutations, 2 factorial. These are the number of ways in which 10 players can be seated at a round table when captain and vice captain are always together, and that's it. Circular permutation when clockwise and anti-clockwise are same. Sometimes there appear a case when the use of both clockwise and anti-clockwise permutation are same, and in that case we treat both of them as same. Like if we have A, B, C and A, C, B. When we were discussing normally what is the difference between permutation and normal circular permutation, in that case we see that these two were different, means the sequence is different. After A there is B, but here after A there is C. So both of them were not different. But when we see that if we consider it as clockwise, sorry, if we consider the first one as anti-clockwise and second one in clockwise direction, then you find that after A here is B, and here in the first one after B it is C, and in the second one in the clockwise direction after B it is C, and this is again same. So when we consider clockwise and anti-clockwise as same, both of these cases will also be treated as one. So here total number of permutation, there is only one possible permutation in this particular case. Now how we solve this in general? We just divide the number of permutations by 2. Why? Because if we have written some permutation like this, then there is a pair of this permutation in anti-clockwise direction also, like this, and they always occur in pair. So what we do the total permutations, total circular permutations divided by 2. This is what we do when clockwise and anti-clockwise are treated as same. For example, in how many ways a garland of 8 different flowers can be made? Since a garland made in a sequence can be flipped to get the same sequence in anti-clockwise direction, like here it is 1 2 3 4. If we flip them, we will find 1 2 3 4 in a clockwise direction, and here we have 1 2 3 4 in anti-clockwise direction, and in this way the clockwise and anti-clockwise can be treated as same because use of both of them will be the same. So here total number of permutations are 8 minus 1 factorial over 2, that is 7 factorial over 2. Find the rank of a word in dictionary. Let me first explain the question. Suppose there is any particular word given here. If we find all its permutations, we don't have to find them one by one. I am explaining the question just.
Suppose we have to find all the permutations one by one. There are all the permutations possible which are written, which are possible are written here. Then we arrange them in dictionary order, and after arranging them in dictionary order, at some place that word will exist, and before it there will be some words, after it there will be some words, whether meaningful or meaningless, no matter. In this order we have to find the rank of this particular word given. So this was our question. Now what strategy we can, if we have, suppose we have to find all the permutations and we have to arrange them in dictionary order, so what strategy or what logic we will use to do this? Let us see. Let's take some simple example or a simple word, you can say, like A, B, C, D, E. Now what can we do? As far as possible, we will try to keep this A fixed and keep changing the values in its left. In its left there are B, C, D, E. In these B, C, D, E also, as far as possible, we will try to fix this this B. In this way we will try to keep fix this C. Then our next priority will be D and then E. This will be the strategy rule with the first simple logic, first necessary condition that we must follow. Now they are written in ranking like A, B, C, D, E. Since they are written in ascending order, so definitely its rank is 1. Next logic that we will use is we will not change. Suppose when we write all the permutations of A, if we have written all the permutations of B, C, D and E, then in last we will obtain something like this: E, D, C, B, A, and its rank will be 4 factorial. Why? Because we have written all the permutations, and after this we have to increase the value of A, otherwise next will not be possible. So this strategy we will follow until all the letters in the left are not in the descending order. We will not change the value of any particular place. So let us see one by one how can we do it. First, in the last place we can assume that it is in descending order, so this time we have to change the value of last second place. For this we have only one choice. After D it is E, so we write A, B, C, E, and in the last place we don't have any other choice, so we will write D and is 2. Now is the here we can see that last 2 are in descending order now, so this time we have to change the value of last third place. After C we will use D, and to write the remaining in the right we just use ascending order, so it is C and E. Okay, again we will start from the rightmost place. Last 2 places, are they in descending order? No, they are not, so we can change their places. C, A, B, D, E, C, its rank is 4. Now they are in descending order, so again we have to change this for the value of this last third place. After D it is E, so A, B, E, and rest of the letters in ascending order. Okay, now change last 2, its rank is 6. Now are the last 2 in descending order? Yes, so we have to change the value of last third. You can see that this time last 3 are in descending order, so we have to change the value of last 4th place, otherwise next permutation is not possible. So after B we will use C, so A, C, and remaining in the sequence of ascending order B, C, C is written, D, E, its rank is 7. As I am talking that all of them comes into descending order after some time, you can see here and here these are in descending order, and at that time we are getting something like ranks like a 2 factorial and 3 factorial. So is it just a coincidence or is it something else? Actually it is not a coincidence really. If we write all the permutations of any particular word, then they will in the last word will be all letters in the last word will be in the descending order, and that's why we are getting like this. So one thing that we will keep doing in finding the rank, we can say that words starting with AB, words starting with AB are are equal to the permutations of the words of the letters which are written in its right. 3 factorial. Let us now understand it with the help of an example. Suppose we have to find the rank of word simple. Okay, so let's first write all of them in ascending order. A B C D E F G H I J K L M N O P Q R S. All of them are in ascending order now. Great. Now words starting with E. How many words start with E? Here in the right of E we have 1, 2, 3, 4, 5 letters. So words that will start with E are 5 factorial. After all these words we will have to change the position of first place. In that case we will write I. How many words will start with I? When I will be in the first position, the remaining will be E, L, M, P, S, something like this. And here the letters, there are 5 letters in the right of I, so again there will be 5 factorial positions. In the case of L also there will be 5 factorial. Then in the case of M there will be 5 factorial. In case of P there will be 5 factorial words, and then S also there will be 5 factorial. But wait, if we find all the words which start with S, where we will reach? We will reach S, P, M, L, I. Everything in the descending order in the right of S, and for now since S is also the largest letter, so including S, all of these are in the descending order. Means we have crossed the word simple. We have crossed the word simple. So this should be this should not be done. This is not the time to do this. Now what we have to do, as far as we reach S, we don't have to find all the permutations in its left, otherwise we will cross the word simple. So we will find all the words starting with S, E. Now after, if we leave S, if we leave E, there are only 4 letters here. Okay, so with SE how many words will start? 4 factorial. After E it is I. Again we have reached I. See, when we obtain the sequence which is given in the word, we just move to the next place and eliminate those elements from the given word. S and I are now on their position. Now so SIE, how many words start with SIE? There are 3 factorial. And how many words start with SIL? 3 factorial. How many words start with SIM? Wait, M is now in the position, so let's remove it. How many words start with SIME? They are 2 factorial. How many words start with SIML? They are 2 factorial. Then how many words start with SIMP? P, we have reached the position, so eliminate it. How many words start with SIMPE? They are now 1 factorial. And after this, how many words start with SIMPL? And we have to write E, so add it 1 for it. Now we have find all the words which are before simple are up to here, so we have to add 1 to find its rank. Means if there are 3 words before simple and after this, here we got the word simple, so all these words plus 1 and we get the rank. So on adding all these numbers here, we will get the rank. Let's take some easy examples also to understand the concept. Suppose we have word alpha. Okay, let us find its rank. So first we will have to arrange it in ascending order: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Great. So words starting with A. Wait, we have find our first letter in the correct place, so eliminate it. Oh, sorry, eliminate it from here. Eliminate it. Now words starting with A. A. How many words start with A? A? 3 factorial. How many words start with A? H? They are again 3 factorial. Now how many words start with A? L? Wait, we have reached the next correct letter, so eliminate it. How many words now start with A? L? A? They are 2 factorial. How many words start with A? L? H? 2 factorial. Words starting with A, L, P. We reached the third correct letter, so eliminate it. A, L, P. After A we will write H. We have reached the correct place, so remove it, and then we have to write A. So you can remove it, but add 1 for this. So on adding all these, we will get our rank. So rank is equal to 3 factorial into 2 plus 2 factorial into 2 plus 1 factorial plus 1, which is equal to 6 to the 12 plus 2 to the 4 plus 1 plus 1, means 2 plus 4 plus 2, 6, 18. It will be on the 18th rank. Now let us see a simple trick also. Let's take the word simple, as we have discussed it, so it will make the things more clear. Or let us take a word in which the letters are repeated also. So suppose we take P-E-A-C-E, peace. We have to find the rank of peace. So we can write A, B, C, D, E, and then P. We will in the simple trick we will do 3 things. First, the numbering, then we will find the permutations in right, and the third thing, less in right, and then repeat. Let's see them one by one, what I am saying. Here we have written all the letters in ascending order, so what we will have to number them one by one. A is 1, C is 2, E is 3. Now if the letters are repeated, give same values to all of them, 3, 3, then P is 4. Right here 1, then 2, then 3, then 4. Okay, first step is done. Now permutations in right. In its right, in the right of P, how many letters are there? There are 4 letters. How many permutations are possible? 4 factorial, and but see that 2 of them are repeated, so we will use 2 factorial in the denominator. Second step is done. Now less in right, count all those values which are less than 4 in its right, means 1, 2, 3, 4. 4 values are there which are less than 4, this 4 here. Now first, then now we have to repeat. In repeat, when we will repeat, just remove this P. Now for E, how many of the permutations are possible in the right with the letters in the right? There are 3 factorial. Great. How many letters are less in right? How many numbers are less than 3 in its right? It is only 1, 2. So multiplied by 2 factorial. Great. It is done. Now for A, how many permutations are possible in the left? There are 2 factorial. How many numbers are less than 1? None of them. 0. Okay. In case of C also, how many permutations are possible? 1 factorial. And how many numbers are less than 2? None. 0. And in last, add 1 for the rank. So this is the rank. 2 into 24 plus 2 times 6 plus 1, which is 48, plus 12 plus 1, 60 plus 161. These are the questions for you, so pause the video and try yourself.
So these were the subtopics for the first video. Remaining subtopics of permutation and combination will be covered in next two videos. Please tell us in comments what modifications you want from us for the series and you liked this video or not. Please share this video with your friends who want to study or revise the topic. If we get a better response from you, we will upload the topics more frequently. Thanks for watching.